When we talk about similar triangles, we talk about two triangles are being similar if they have equal corresponding angles. This word corresponding just means the same angle on each triangle. Okay, you can see here angle C and angle F correspond. Okay, this triangle is bigger than this triangle, but the C and F are like the same angles. Angle E and angle B are the same angles. Angle A and angle D are the same angles. Now they say they have to be equal because even though this triangle is bigger, remember that the three angles in a triangle have to add to 180 degrees. So even if this triangle is bigger, this angle plus this angle plus this angle has to equal 180 degrees. So the angle measures don't change if they're similar. They're going to equal the same thing. So if we say this angle is let me do a better example than that. If we say this angle is 95 degrees, then this angle has to be 95 degrees. Okay. It also says, though, it can be shown that this is equivalent to the ratios of the lengths of corresponding sides being equal. And this always tends to confuse people, but it's a pretty simple idea. Basically, if two triangles are going to be similar, if you take this side, and let's just say this side was 5, okay, and this one's 10. That means what I did to 5 to get 10 is I multiply it by 2. So this side would be 2 times as long as this side. Well, does that mean we can take, let's use this side. Let's say we can take this side here, which is 8, and we can multiply that by 10, and this becomes 80? Does it, I mean, if you have a triangle, and we're going to double this length here to get 10, and then we're going to multiply the bottom by 10, so we're going to go times 2, and then here we're going to go times 10. All of a sudden, we have this super long line on the bottom. Is it similar anymore? Does it look like the original triangle? I mean, that's basically what similar triangles mean. The two triangles look alike, just one's bigger than the other one. No, that you can't multiply by different numbers if they're going to be similar triangles. So, when we talk about the ratios of the lengths of the corresponding sides being equal, it just basically means if you choose to multiply this side by 2, you got to multiply all the other sides by 2. The ratios have to be equal. So that should be 16. Now if you notice, the length of AB is 5, the length of DE is 10, the length of AC is 8, and the length of DF is 16. And I had just made up those numbers. But notice that these both equal 1/2. Their ratios are the same. Okay, you can think of this as being half as big as this one, or you can think of this one as being 2 times as big as that. So let's try an example. The two triangles are similar. That's important. We know if they're similar, that their angles, their corresponding angles are going to be equivalent, and the ratios of the lengths of their sides are going to be equal. So, two triangles are similar. What is the length of side RS? So we want to find this side right here. Here's my hint. Whenever you want to find your unknown, start by writing that down. I want to know what RS is. And I'm going to set up what's called a proportion, which is basically just an equation. Okay? So, here's what I do. I write down what I want to know, and then underneath it, I'm going to write down what its corresponding side is. So, here's RS. That corresponds here. Notice it's a right angle and one line. Here's a right angle and one line. So these are going to correspond to each other. So I'm going to write x over 4. And then I'm going to put over here another side on this triangle. We could use either one, okay, if there was a number here. But since this is 6, I'm going to put it here. Now what corresponds to side TS? PN does. So under the 6, I'm going to put an 8. If you think back to when we learned how to do proportions, it's very important that we set them up, so they go together horizontally and vertically. X over 4, these are two corresponding sides. 6 and 8 are corresponding sides. X and 6 are the same figure. 4 and 8 are the same figure. Okay. Now there are different ways we can solve proportions, and basically all a proportion is an equation that sets two ratios equal to each other. So if we treat this like an equation, we can say, okay, what are we solving for? X. What do you have to get rid of? 4. Well, it's being divided by 4, so how do we get rid of it? Multiply by 4. whatever we do to one side, we have to do to the other. So if we cross reduce, 4 goes into itself 1 time, 4 goes into 8 2 times. This ends up being 6 times 1, which is 6, over 2 times 1, which is 2. And we can definitely reduce that more, 6 divided by 2, or if you reduce it saying 2 goes into itself 1 time, 2 goes into 6 3 times, we get an answer of 3 centimeters. Now, that's the way I would set up this proportion. Remember, as long as we line them up horizontally and vertically, it could be different. Let me just show you that real quick. I could say, okay, I know x and I know 6, so I can line them up saying, here's our unknown, here's the 6. They're both on the same figure. What corresponds to x? 4 does, so I can put 4 here. What corresponds to 6? 8 does. Okay, again, notice that this proportion looks different from the original one we set up, but it's lined up vertically, same figures, and horizontally, corresponding sides. If we were to solve this, what are we solving for? X. What do we have to get rid of? 6. It's divided by 6. How do we get rid of it? Well, we multiply by 6. Whatever we do to one side, you do to the other. We're left with x equals, if we cross reduce, 2 goes into 8 4 times, 2 goes into 6 3 times, 4 times 3 is 12, divided by 4 times 1, which is 4. Oh, and look, we end up with 3 centimeters. Okay, so as long as you're careful to set things up so the corresponding sides are either up and down from each other straight across, and so it's the same figure, the same sides of the figure, you're going to get the correct answer.